Hello, and welcome to Indices Part 1. So, let's start by explaining what is an indice. So, an indice is any number to any other number, and this highlighted in yellow here is called the base. That. And this highlighted in green here is called the index. Okay, so what does that mean? It means that we're timesing our base by n amount of times. So a quick and easy example is 2 to the 3. We're timesing 2 3 times. Yeah, okay. Now that we know that out of the way, now that we have that out of the way, we can start talking about the laws of indices. So the first law is this: a to the m times a to the n is equal to a to the m plus n. Okay, so how does that work? Okay, well, it's best to look at an example and why this works. So a is some sort of fixed variable. Let's just say that a is equal to 2 for the time being, yeah? Okay, so if I had 2 to the power of 3 times 2 to the power of 2, what's that? Okay, so we already know that 2 to the 3 is just 2 times 2 times 2, right? Put that in brackets, times our 2 to the power of 2, 2 times 2. Okay, so if you look at the brackets, yeah, that we really don't need them, so we can just get rid of these. And now what do we have? Well, we have 2 times 2 times 2 times 2 times 2. And there's 5 2's there. So we can see that it's just simply 2 to the 5. We can rewrite it as 2 to the 5. And we can see that 3 plus 2 is indeed 5. So this law has to work as long as a is equal to some number, and no. This rule will work as long as the two bases that we're trying to add together are the same. Okay, let's look at the second law. The second law is basically an addition to our previous law. If we have a to the m divided by a to the n, we're going to get a to the m minus n. Okay, so let's take a look at this as a fraction. And let's use our example 2 again. So a is equal to 2. So let's do 2 to the 3 divided by 2 to the 2. And that's equal to 2 times 2 times 2 over 2 times 2. Okay, so these cancel. They just turn into 1. We now get 2 over 1, which is just equal to... We now get 2 over 1, which is just equal to 2. Okay, so that's the second law. So let's look at the third law. The third law is anything to the power of 0 is 1. Okay, so how do we prove this? Well, we can use the second law to prove this. So if I had a to the 2, we don't need to define a for this, and I want to divide it by a to the 1, or just a, I'm going to get a again, right? But if I... Okay, so if we now have our a, So a divided by a, it's just a to the 1, is going to equal to a to the 1 minus 1, right? Which is 0. So a to the 0. So if we plug in 2 is equal to a, we get 2 divided by 2 is equal to 1. And that makes sense because it's just 2 to the 0. Remembering that if it doesn't have an indices, it's just to the power of 1. Okay, so let's move on to the fourth law. Okay, so this law states that if you have a to the m, and that's to the power of n, but it has to have the brackets here, that is the same as a to the m n, right? So all we're doing is timesing these two things together. Okay, so let's look at a real world example. No. Let's look at an example. We have 2 to the power of 3. Well, that's just 2 to the 3, yeah? You have the 1 here. Okay, let's look at another example. We have 2 to the 2 to the 2. Okay, so according to our law, this should equal 2 to the 4. Okay, so let's evaluate what that is. So 2 times 2 is 4, times 2 is 8, times 2 again is 16. It's equal to 16. Okay, so let's work out what 2 to the 2 is. 2 to the 2 is 4. So we're saying that 4 squared is the same as 16. Is 4 squared equal to 16? Yes, it is. 4 times 4 is 16. Okay, let's look at the fifth law. This isn't really a law in my opinion, but I guess it makes sense to make it one. Alright, if you have a times b to the power of m, right, in brackets, that is the same as a to the m times b to the m. And if you think about it, that's very logical, as we saw with the fourth law. So if we had 2 times x, or 2x to the 2, we're going to get 2 to the 2 times x squared, which is the same as 4x squared, yeah? Okay. Let's look at the sixth law. This I also think isn't really a law, but here we go. So if we have a divided by b, and that's all to the power of m, that is the same as a to the m over b to the m. And the reason why I don't think this is a law is because whatever you do to the top, you must do to the bottom to make it the same number, right? So by putting it in brackets, all you've done is saying that fraction there to the power of m. So if we think about it, we use 2 over 1 to the power of 2. 2 to the 2 squared is 4. 1 squared is 1. We get 4. Yeah? Makes sense. Alright. Now let's talk about negative indices. So if we have a base to the power of a negative number, that is the same as 1 divided by that same number to the power of that positive index. And this works both ways as well, and as I will show you. Alright, so let's look at an easier way of looking at it. 2 to the 2 times 2 to the negative 2. Alright, we know from our first law that's going to be 2 to the 0, right? Which is equal to 1. Alright, that's good. We know that. Alright, if I divide both sides, no. If I divide both sides by 2 squared, I'm going to get 2 to the negative 2 is equal to 1 over 2 squared, which is 1/4. Yeah? Does that make sense? So let's look at another example. So 3 to the negative 9 times 3 to the 9, and that's equal to 3 to the 0. Divide both sides by 3 to the 9. We get 1 over 3 to the 9 is equal to 3 to the negative 9. And okay, if you have a test on indices, don't leave it as a negative indice. Turn it into this fraction form here. It just shows more understanding that this is true, and it shows your understanding of the laws and how they work and all the rules attached to it. So that's it for today's video. If you have any questions, feel free to ask me on social media or in the comments below, and I will see you in the next video.